Good day, students. Welcome. Today we are going to discuss the topic 7 of this course, which is the reservoir capacity calculations. So this will be for the authors and contributors of this material, and here is for the copyright notice. For the intended learning outcomes, after this lecture and exercises, you the students must have first, describe the methods and procedures to estimate reservoir capacity, differentiate the methods and procedures to estimate reservoir capacity, memorize formulas in reservoir's capacity calculation, and lastly is to perform calculations to determine the reservoir capacity. For the outline of the presentation, again, we have two parts for this material. The part 1 will be the cross-section method of reservoir capacity calculations, and for the part 2 is the contour method. Without further ado, we're going to discuss the part 1, which is the cross-section method. But before that, we are going to have an overview on how or what is a capacity of lakes and reservoirs. So in the design of water supplies and systems, irrigation projects, structures for aquaculture development, and hydroelectric power generating station, it is necessary, kinahanglan jud ta dapat nga mahibaw-an ang volume of the water of that specific water body, which could be contained and generated by supporting reservoir or a lake. So before any project like this one, water supply systems, irrigation projects, for example, if you have seen or if you are familiar with the Opagan na irrigation system in Butuan City, located at Barangay Opagan. So there is a reservoir or pond, before na siya i-release into the by the way, si Opagan irrigation system is a pumping station, na siya pumping station, which is mo na siya ang mag-supply og water sa irrigation system sa Butuan City. So the water of that irrigation system is came from the Agusan River, So there is a pumping station that pumps water, from the Agusan River, and ibutang siya dito sa specific pond or kanang gitawag nilang reservoir. From that reservoir, it takes pila ka days, 2 days and 3 days to settle the sediments, and after the 2 to 3 days, ilan na silang i-release into the irrigation system. So by that time, ma-release na ang tubig gikan sa reservoir padulong na dayon sa mga basakan. So by that example, so it is really need to calculate the capacity of that reservoir or that pond, so that we can so that the irrigation system nga ga-operate ana niya is mahibaw-an nila kung how many cubic meters ang ilahang mahatag sa basakan or sa mga farmers using the estimated volume of the pond or reservoir. So the capacity of body of water is always determined prior to any construction and subsequent filling. So again, kinahanglan any constructions na mo undergone or mo tackle or shall we say any constructions na mo deal with waters, for example irrigation system, bridges, yan ang mga construction. It is always a necessary or a necessity to determine the capacity of that specific water before the construction begins. And the capacity to contain water is expressed usually in cubic meters or in hectare meter. Pero ang pinakasikat sa tuwa is cubic meters. So when we say hectare meter, it is the volume of water 1 meter deep, 1 meter deep and 1 hectare in extent, or that is 10,000 cubic meters. So let's start with the cross-section method. So the cross-section method is a commonly used when a moderate degree of precision is required in determining the effective capacity of the body of water. And cross-section method is suited in the surveys like lakes and reservoir with a uniformly defined cross-sections and where a reference baseline could easily be established. No? Okay, since naman siya, for example, irrigation canals, uniform ang iyahang cross-sections. Where reference baselines could easily be established along a shore and parallel to the center of the lead of the body. So in short, usually ginagamit ni siya or it is very well suited kung ato ang for example canal no is nasa uniform na cross sections. Kung trapezoid tanan, kung rectangle tanan ang iyang cross sections. So the concept of the cross section method is same lang gihapon sa pagkuha sa atong discuss from the previous lecture in the topic 6 about the stream gauging or the measurement of the velocity of the stream. No? So in the cross section method, so we need also to get the area of the cross sections. For example, let's say this is the reservoir or the pond. No? So we're going to establish a range line. No? This is a range line. So like what you did in your laboratory exercise number 2, that you have established a range line. So in every pond, no, dapat na kay series of range lines. Then out from the range lines, for example, in range line B, so this one, so you need to have a series of verticals, and from that verticals you get the depth of the specific vertical, no? And also you have determined the distance between that verticals, no? So as the range line C, range line D, and range line E. Then after that, you get the area of that specific range line, from, like for example, the total cross-section of range line A, or range line B rather, and total cross-section for range line C, and total cross-section for range line D. And from that, we are going to use the Prismoid formula, no, in determining the volume. So that is the concept of the cross-section method. So in this method, the following steps are being performed. So these are the series of steps that we are going to use, no, on how to do the cross-section method. First is lay out parallel ranges across the body of water at the selected points, no? For example, this one, this is the series of range lines. So range line B, range line C, and range line D. Range line A is the point of starting, no, or the reference, or the right water edge and left water edge, or the upper edge and lower edge. The range line should be established nearly perpendicular as possible as to the reference baseline. So from this figure, no, so you have here the reference point or reference baseline. So dapat daw perpendicular siya. Perpendicular as much as possible. And take soundings at various points on each of these ranges. So, take soundings. So if you have this range line B, so you are going to take soundings, no, or the verticals, no. So out from that verticals, you get the depth, no. Sounding is for depth. And where the bottom of the lake or reservoir is fairly regular, the spacing of the soundings on each range may be uniform. So in this case, no, as you can see, the figure of the pond or the reservoir is irregular. So there is a high possibility rather, no, that the seabed, or no, the pond bed or the bottom of this water body is also irregular. So according to this procedure, that if you have a uniform bed of the specific water bodies, your soundings or your verticals may be uniform, no? Kay since dili man kay siya, wala siya ay changes. Like for example, irrigation canal, no? So uniform man ang iyahang bed. So therefore, the spacing of the verticals is uniform. And from this example, since it is not regular, no, and it is not uniform, so take soundings or point the the verticals or the intervals on the elevation when there is a sudden changes, no. Kung hibawaan ninyo nga na changes of elevation, then take soundings at that point, no? Like for example, in this one, no, so diri nga part is yan siya katas on ang iyang depth. So ang next sounding nimo bisan tana is naa sa at a specific interval. So you have observed that there is a sudden change at this point, so dapat kuhaan pud nimo siya og soundings na para ang imong approximation or ang imong estimation sa cross-sectional area is as accurate as possible. And soundings, however, may have to be taken as nearly as possible at significant changes in the slope of the bottom. So, mo na kong giingon kaganina. So, next is, in shallow area, soundings may be performed with the use of soundings or soundings rod and by wading through the water. So, pag mabaw lang, so, pwede lang siya nga rod, no? Or sounding rod. Kay mabaw lang man. Pero pag lawm na siya, so, we can use a boat, no? And taking sounding equipments. The sounding line released from a small boat is used in deeper sections of the lake. So madong gingon na if di na siya kaya sa isa ka ay surveyor, so we need a small boat, no? Basta bangka, pwede na siya. When the length of the range line is significantly long, the process of locating soundings may be stretching a rope may no longer be feasible. Other methods of locating soundings should be employed. So, kung hindi na siya makaya og binat-binat na og PC, so another equipment like for example, echo sounders or a boat with sounding equipment equipped nga boat, no, which can be used, no, nga dili siya dali madala sa current sa tubig. And next is we are going to determine the area of those cross sections using the sounding nga na take nato sa range line on each of the several parallel ranges from the soundings and the horizontal distances between the soundings. And for a typical cross section, the area of each partial section is determined by either each area of a triangle or area of a trapezoid. Same as we do in the topic 6 in getting the cross sections. So, for the example or for illustration, for example, this is the right water edge and this is the left water edge. And we have here area 1, 2, 3, 4, 5, 6, 7. So, for area 1 and area 7, we're going to use the area of a triangle, formula for area of triangle, and in the middle, like for example, 2, 3, 4, 5, and 6, we're going to use the formula for getting the area of a trapezoid. And to get the total area of this cross section or this range line is just add all the areas that you've computed from area 1 until area 7. Next is to compute the volume of the prismoids between these sections. The volume of the water between successive ranges is determined by averaging the areas of two cross sections and multiplying by the distance between ranges. The volume of the prismoids between successive cross sections are then computed as, no, so in getting the volume, pasabot lang niya class is in getting the volume of two successive ranges, no, or range lines, no. So you have here is you have a range line that you get the area, and next is another range line that also you have get the area. So imo na siyang i-add ang duha ka areas divided by 2, times the distance between the two range lines. So that's what we call the area of the, or volume of the prismoids. So this is the formula. Now, for example, for ranges A and B, so you're going to just to add the two areas of between ranges A and area of the ranges B divided by 2 times the distance between range A and range B. So as the volume for between ranges B and C, C and D, and D and E. So it is required, or it is necessary to determine the horizontal distance between cross sections. For example, this one, no? For range line A and range line B, we need to determine the distance between two of that ranges. No? For example, range line A and B, so we have distance 1. No? And these distances are defined by markers set up along the reference baselines. So for example, this is your reference baseline. So you have here range line A to range line B, D1, D2, D3, and D4. And to determine the volume of the entire body of the water, it can be determined by adding all the partial volumes of the general prismoids into which the body is assumed to be divided by across the sections. So to get the overall volume, just add all the partial volumes. Like for example, volume for ranges A and B, volume for range line B and C, volume for range line C and D, and volume for range line B and E. So you can have now the total volume. So let's have a sample problem. So in the accompanying plot, the boundary of the water surface of a reservoir is shown by the irregular outline A, B, C, D, E, F, G, H. Soundings were taken on the parallel ranges BH, CG, and DF for the purpose of determining the volume of the water in the reservoir. The number on the plot show the horizontal distances in meters, which were measured for locating the ranges of the soundings, and also the depths in meter, which were measured where soundings were taken. So this is the accompanying illustration of the sample problem. So we have here soundings at the range BH, range CG, and range DF, and also the soundings at the specific verticals in the specific ranges is also known, and the distances between two ranges are also given. So we need to calculate the following: the areas in square meter of the cross sections of ranges BH, CG, and DF. Assume that the cross-sectional areas of the range A and E are negligible or nearly zero. Okay, since dito man ang point, no? Mura na siya, it's a point, no? So wala na siya cross-sectional area. Next that we are going to calculate is the volume in cubic meter of water between ranges. So between ranges A and BH, ranges BH CG, and ranges CG DF, and lastly is the DF E na ranges. And lastly is to calculate the total volume in cubic meter for water contained in a reservoir. So first is we need to solve the cross-sectional area at range BH. So here is the accompanying figure. So first is we need to determine the area between ranges 1 and 2 in this part. So since it is a triangle, so we need to use the formula for area of that triangle. So we have 1/2 times 1.2, which is the depth, and 2.5 is the distance, or the distance between the verticals, which is 2.5. So we have 1.5 square meters. Next is for verticals 2 to 3. So we have 1/2 times 1.2 plus 3.0 times 2.5 distances. We have 5.25 square meters. No? For area of the ranges 3 to 4, we have 1 half times the quantity of 3 plus 0, 3.0 plus 3.6 times 5.8. So we have 19.4 square meters. Next is for the area between between verticals 4 to 5. So we have 1 half times the quantity of 3.6 plus 1.8 times 4.6, that is equal to 12.42 square meters. And lastly is for the verticals 5 to 6. So since this is a triangle, so we need to use the formula for area of triangle. We have 1 half times 1.8 times 3.0. So that's result for 2.7 square meters. And to get the overall cross-sectional area of these ranges is we need to sum, no, of these areas. No? So we have summation of all the cross-section areas. That leads to 41.01 square meters. Next range, or the next range line, is the range CG. So this is also the accompanying figure. Same process for determining the cross-sectional area. So area for verticals 1 to 2 is just the 1 half times 4.3 times 7.3, that leads to 15.695 square meters. Area for verticals 2 to 3, we have 1 half times the quantity of 4.3 plus 4.6 times distance of 5.5, that is equal to 24.475 square meters. Area for verticals 3 to 4, so 1 half times the quantity of 4.6 times 5.5 plus 5.5 rather times 7.9 is equal to 39.895 square meters. For area 4 to 5, or area of the verticals between 4 and 5, we have 1 half times 5.5 plus 5.5 times 3.9, that results to 21.45. For area 5 to 6, or area of the verticals 5 and 6, is 1 half times the quantity of 5.5 plus 4.3 times 3.9 is equal to 19.11. And lastly, for areas of verticals between 6 to 7, so we have 1 half times 4.3 times 7.3, that is equal to 15.695 square meters. And for the total cross-section, or the total area for the cross-sections, or the cross-sectional area of the range CG is equal to 136.32 square meters. Next is for the range DF. So first is again same procedure. So for verticals 1 to 2, we have 1 half times 4.3 times 6.4, that leads to 13.76 square meters. Next is between verticals 2 to 3, we have 1 half times 4.3 plus 4.5 times 6.1, that is equal to 29.89 square meters. Next is for verticals 3 to 4, no, or verticals, area of the verticals between 3 and 4. So 1 half times 5.5 plus 6.1 times 7.3, that is equal to 42.34 square meters. So for area of the verticals between 4 and 5, we have 1 half times the quantity of 6.1 plus 6.1 times 8.5 is we have 51.85 square meters. And lastly is for vertical 5 to 6 is 1 half times 6.1 times 8.9, that leads to 27.145 square meters. And for the overall area of the cross sections is we have 164.895 square meters. So next that we are going to solve is the volume between ranges. Now, so we have here the volume or the partial volume of the range line A and range line BH. Now, so to solve this one is we have the distance between the two range lines, which is 11, no, in this case, and the cross-sectional area of range line A, which is negligible, so the 0 siya, and which is also stated in the problem. No? And the volume for range line BH is 41.01 divided by 2, no? So which results to 225.555 cubic meters. Next is for the volume or the partial volumes between BH and CG. So we have the distance between the ranges is 13 times the quantity of the area of the range line BH is 41.01, and the cross-sectional area for the range line CG is 136.32 divided by 2, no? That results to 1152.645 cubic meters. Next is for the partial volumes between the range lines CG and range line BF. So the distance between two range lines is 16.5 times the quantity of the area of the range line CG is 136.32, and the range line BF cross section is 164.985 divided by 2. That leads to the volume to be 2,485.76625 cubic meters. And lastly is for the partial volume between the range lines DF and E. So the distance between them is 14.6 times the area of the range line BF is 164.985 plus 0, which is the cross-sectional area at range line E, which is negligible according to the problem. So we have the value of 1,204.3905 cubic meters. And to determine the total volume of the pond, no, of the reservoir, it's just the summation of all the volume between ranges, or the summation of the partial volumes. So if we sum this one, we can have the value of 5,068.35675 cubic meters. Alright, so let's go now to the part 2 of this material, which is all about the contour method in the reservoir capacity calculations. So contour method, so the reference baseline or a shore traverse is established from which the water line and the desired shore topography is being located. And for a small elongated reservoir, soundings may be conveniently taken at regular intervals, no, along parallel range lines. So same gihapon sa pamaagi sa cross-section method, no? So if ang reservoir daw is elongated, no, the soundings may conveniently taken at a regular intervals along parallel range lines. Same gihapon ang pamaagi sa pagkuha sa cross-section areas, no? Ang diri lang sa contour method is you need to have a to do the sounding, no, and ang output niya is you need to have a contour of the reservoir. So maghimo kag contour map, no, which is ang same elevation is naa siya same contour, no, contour lines, no? Mamanay essential, di ba? Kung na kay contour, so expected nga same na siya og elevations, no? So mo take yapon kag soundings, no, sa isa ka reservoir, then ang katong nga depth is imo siyang gamitan to generate a contour map. And the spacing of the ranges and the soundings along them may be sufficiently close to clearly define the slopes of the reservoir bed and where there is a significant difference in depth between adjacent measurements. The same note as the cross-section method, no? Kung atong na sudden changes or significant changes, dapat kuhaan siya og depth, no? The elevation of the water surface is determined by leveling from a benchmark, no? So mura mo og nag-topographic survey, no? Pero sa water, no? On a prepared map of the reservoir or lake, no? The subaqueous contours are then plotted from the sounding elevation covering the area between the water surface, no? So di ba pag nata sa land, no, topographic contours na siya ang tawag, di ba, sa katong contour with same elevation. So in water, so we have this what we call subaqueous contours. No? So this is the contour line or the contours uh, under the sea or under the water. No? And the area enclosed by the water line and each contour is determined by the use of planimeter or by the counting full and partial squares as enclosed to the contour when plotted to cross-section papers. So it is then plotted to planimeter. Also, you can do the interpolation to get the specific point, no, or specific elevation between two soundings. No? Then imuha siya, you can use also the squares, no, magbuhat kag rectangle or squares, no, na elevation diri, na elevation at between elevation between the elevation of the corners of the square, then mag-interpolate ka, no? So that is the conventional use method on how to do the contour map. The average of the enclosed areas at two consecutive contours is being multiplied by the contour interval. So we have contour interval or CI between two contours, or vertical distance between them gives the volume of water lying between two contours. So i-add mo ang area, i-add mo ang duha ka area between successive contours, then divided by 2 times the contour interval. So, nga na gyapon pag prismoid gyapon ang formula. This is actually similar to computing the volume of a prismoid. So, muna siya kung pasawot ka ganina, prismoid formula. And a summation of partial volumes between successive contours up to the maximum water level gives the capacity of the lake of water. So, ang iyahara yung goal ani or ang iyaharang concept is merge po siya cross-section area, but ang area nga atong gamiton diri sa contour method is the area of the contour, no? So di ba kagaya na cross section, so ang cross section atong gigamit nga area diri sa contour method, ang area sa contour times dayon nato sa contour interval. So the volume between bottom and contour and the deepest part is usually small and may either be estimated or neglected. So sa bottom na part, no, katong pinakailalim na jud, so the area can be neglected since hindi na kay siya mumatter, no, kay gamay naman siya, mura padulong siya sa point. And the accuracy of the measurement will depend largely on the manner of which soundings are taken, no? So ang importante jud na part is pag take nimo soundings, no, kung naa kay ma-miss na naay significant changes sa elevation, so that will affect your estimation or determination of your volume. Also, by plotting of the subaqueous contours and the determination of the areas enclosed by each contours. So, dira magmatter ang ato ang accuracy. So, the volume of a water contained between consecutive contours is determined by using this formula. So, parehas na gyapon kagina sa pagkuha sa volume sa cross sections. It's just volume is equals to H times area I plus area H divided by 2. So, where V is the volume of the prismoid or volume between any of two consecutive contours, so that is in cubic meters. And H is the contour interval or the vertical distance between two consecutive contours in meters. And area I or area L, no, this is the area enclosed by the lower contour, tong pinaka bottom, no, which is in square meters, and area H, which is denoted as area enclosed by the higher contour in square meter also. And the total volume of a water contained in a reservoir or lake is the sum of the volumes of the prismoids. And in general, so pwede natin siya gamitin nga formula. Diba? Kaganina is kani, no? This is for the partial volumes. And at kung imo na siyang i-add, ang tanan volumes, partial volumes, it will give you the total volume of the reservoir. So, you can also use this formula, no? This is the prismoid formula. So, it is V equals to H times AO over 2 plus AI plus AN over 2, where V is the total volume and H is the contour interval, and AO is the area enclosed by the boundary of the water surface. So katong pinakataas ni siya, no? Area or the water surface area sa contour. And AI is the sum of the areas enclosed by all intermediate contours considered, no? So mo ni siya ang total area sa between the water surface contour area and the bottom, no, or the lower area. And AN is the area enclosed by contour at lowest level. So this is in square meters. And alright, so let's go to the 4D sample problem. So from the results of a hydrographic survey of a lake, the following data are being obtained. We have area A to be 1,240.71 square meters. This is the area enclosed by the boundary of the water surface. So pinakataas ni siya nga contour. And area B to be 792.79 square meters. So this is the area enclosed by contour B. And area C is equals to 397.77 square meters. So this is the area enclosed by contour C. And area D to be 178.44 square meter. So this is the area enclosed by contour D. And area E to be 48.33 square meters. So this is the area enclosed by contour E. And if the vertical distance H, no, or the contour interval between two contour levels is 1.5 meters, we need to determine the total volume at water in the lake above the level of the contour E. So this is the illustration of the problem. Now, so you have here contours, and we have an H, we have the water line, and the contour interval or the CI. So in solving this kind of problem, we need to have the two approaches. Now, katong we are going to use the two consecutive contours, or mugamit ta adtong partial volumes, or mulargo ta adtong volume using the formula for Prismoid. So first is we need to have the partial volumes, which is the area between two consecutive contours. So we have here the given, no, areas. So for area between contour A and B, we have contour interval to be 1.5 times A times the quantity of area of contour A, which is 1,240.71 square meter, plus area of contour B to be 752.79 all over 2. That leads to be 1,495.125 cubic meters. For the volume between the contours B and C, so same equation or same formula that we are going to use. We have 1.5 as H, or contour interval, times the quantity of area of contour B, which is 752.79, plus 397.77 divided by 2. That leads to be 862.92 cubic meters. Next is for the volume between the contours C and D. Now, so we have H to be 1.5 times the quantity of the area of the contour C to be 397.77, plus area of the contour D to be 178.44 divided by 2. That is equal to 432.1575 cubic meters. And lastly is for the volume of the between contours D and E. Now again, so the contour interval is 1.5 times the area of contour D to be 178.44, plus area of contour E to be 48.33 divided by 2, that leads to be 170.0775 cubic meters. And to get the total volume of the reservoir is just the summation of all the volume between ranges, or the partial volume. So kung ato ni siyang i-add, mo ni siya ang total volume. So the summation of the volume between ranges is equal to 2,960.28 cubic meters. So this is now the total volume for reservoir, which is mo gipangita sa problem. So another approach is we need to apply directly the prismoid formula. No? To do that, so this is the formula. No? Volume times H. No? H is the contour interval, which is 1.5 times AO divided by 2 plus AI plus AN divided by 2. So substitute the variables, no? The value for the variables, no? So we have V is equals to 1.5, which is the contour interval. The AO is the area of the upper of the top or the water surface na contour. So that is 1,240.71 square meter divided by 2 plus, so si AI is the sum of the area between the upper and the lower. So mao ni siyang naadiri is 752.79 plus 397.77 plus 178.44 plus AN, which is the area of the contour in the bottom level of the reservoir, which is to be 48.33 square meter divided by 2. So if we do this in the calculator, no, kung ato siyang input sa calculator, so we can have the total volume of the reservoir is equal to 2,960.28 cubic meters. Same sila sa katong partial volume sa atong gigamit. Alright, so I think that ends our discussion on the topic 7, which is all about the capacity of the reservoir and or reservoir capacity calculations rather. No. So again, if you have questions and clarifications with this lecture and material, you can approach me through our FB page and LMS chat. No. So if na may kalibugan, so i-chat lang ko, approach lang ko. And I hope that these video lectures will supplement your knowledge and learnings in studying hydrography subject and hydrographic surveying subject. And no, ma-supplement ang inyong learnings, no. Dili lang kay lisod ba kayo ang panahon karon kay purely online na ang tanan. No, so thank you so much for watching and stay tuned for another video lectures of this course. Keep safe everyone and good day.